This alliance network should prevent surprises entirely, correct?
In doctrine, the integrated network links F-35 sensors, Wedgetail command nodes, and surface combatants like Mogami frigates into a continuous kill chain. Detection, identification, and engagement are designed to operate seamlessly through shared data links, enabling distributed lethality across maritime and air domains.
So targeting and response happen almost instantly across platforms?
Yes, the system relies on real-time data fusion, where F-35 provides forward sensing while Wedgetail coordinates targeting solutions for naval and air assets. Mogami-class frigates then act as shooters, using vertical launch systems to engage threats based on network targeting inputs.
And this layered setup covers both air and maritime threats?
Correct. Integrated air and missile defense combines airborne early warning, stealth detection, and ship-based interceptors to create overlapping defensive layers. In theory, this architecture minimizes gaps and ensures continuous coverage across the Indo-Pacific operating environment.
So as long as the network holds, nothing really slips through?
Under controlled conditions, the system maintains high reliability, though its performance still depends heavily on uninterrupted connectivity between nodes.
So, where does this system actually operate in practice?
The architecture is designed for Indo-Pacific operations, spanning vast maritime distances from northern Australia to the first island chain near Japan and Taiwan. It must function across contested airspace, long-range sea lanes, and areas covered by adversary A2AD systems designed to deny access.
And the primary opponent shaping this environment is China? With missile ranges already covering key Australian bases?
Correct. The PLA rocket force field systems like DF-26 capable of reaching northern Australia, while layered ISR tracks movements across the region. At the same time, Chinese naval and air forces operate within dense sensor networks, creating persistent pressure on any forward-deployed assets. The environment also includes electronic warfare, cyber disruption, and degraded satellite coverage, all affecting how the kill chain performs in real conditions. This means systems like Wedgetail and F-35 must operate while managing contested spectrum and uncertain data integrity.
So the network is no longer operating in a clean data environment?
Exactly. The system assumes reliable connectivity, but under pressure that assumption becomes conditional and performance can vary depending on access to the electromagnetic spectrum. In theory, the architecture still functions, but under sustained operational stress, coordination across nodes becomes more complex than originally designed.
If Wedgetail loses track briefly, does the kill chain pause?
The kill chain is designed with redundancy, but target tracking continuity depends on persistent sensor input from platforms like F-35 and Wedgetail operating together.
But under EW pressure, that tracking is not continuous anymore? So data latency starts affecting targeting accuracy across the network?
Yes, electronic warfare can introduce delays or gaps in the data link, which affects how quickly targeting solutions propagate across the network system. In those conditions, F-35 may still detect targets, but passing that data reliably to a Mogami frigate or other shooter becomes less consistent. The system assumes near real-time data fusion, yet under contested spectrum conditions, latency can increase from seconds to longer intervals that matter operationally.
And moving targets require constant updates, not static coordinates, correct?
Correct, especially in maritime operations where ships maneuver continuously, requiring updated tracking for effective missile guidance and engagement timing.
So if updates slow down, intercept probability starts dropping?
Yes, engagement quality depends on tracking fidelity, and degraded updates reduce the effectiveness of missile intercept solutions over time. This does not immediately break the system, but it introduces friction into what is designed as a seamless kill chain, reducing overall responsiveness.
And that friction compounds as more nodes rely on shared data simultaneously?
Exactly. The more interconnected the system becomes, the more sensitive it is to disruptions, especially under sustained electromagnetic pressure. Under these conditions, performance begins to diverge from design expectations, and that gap can widen significantly as operational stress increases.
What happens if 50 inbound missiles arrive simultaneously? And drones mixed in at different altitudes and speeds?
In that scenario, layered defense prioritizes threats, with Mogami allocating its 32 vertical launch cells across incoming targets based on threat assessment. Systems like Wedgetail and F-35 continue feeding targeting data, but engagement sequencing becomes constrained by finite interceptor availability and processing bandwidth. Under saturation, interceptors are expended rapidly, and once the vertical launch cells are depleted, the ship must rely on limited close-in systems.
So the ship runs out of missiles within minutes.
In high-tempo engagements, yes, expenditure rates can exceed replenishment capacity, especially since reload at sea is not feasible during active combat.
And tracking still depends on stress data links?
Correct, and under concurrent EW pressure, data degradation compounds the problem, reducing targeting accuracy as the system attempts to manage multiple threats simultaneously. This creates a condition where prioritization replaces full coverage, meaning some incoming threats are deliberately not engaged due to limited resources.
So defense becomes selective rather than complete?
Exactly, and this is where the system shifts from optimal interception to damage limitation under constrained conditions. This only works within limited thresholds, and once those thresholds are exceeded, defensive effectiveness declines sharply as more threats penetrate the system.
And if the attack continues beyond initial waves?
Then the system faces cumulative degradation, where coordination, ammunition, and sensor reliability all begin to erode, making sustained defense increasingly difficult.
If saturation breaches one Mogami, what happens to nearby units? Does the defensive gap spread across the wider task group?
Once a node like a Mogami frigate loses interceptor capacity, adjacent units must compensate, stretching their own limited vertical launch inventories and sensor attention. This redistribution creates uneven coverage, where some sectors become underdefended, especially during multi-axis attacks across maritime approaches. In parallel, Wedgetail and F-35 continue feeding data, but prioritization delays increase as more targets compete for limited engagement windows. This leads to cascading delays under sustained pressure, where kill chain timing no longer matches incoming threat tempo.
So missiles start slipping through despite the layered defense design?
Yes, not because the system fails entirely, but because engagement capacity becomes saturated and selective under operational constraints.
And what happens to coordination between air and naval elements then?
Coordination becomes reactive rather than predictive, with forces responding to penetrations instead of maintaining proactive denial across the battle space. Over time, this reduces effective coverage, particularly in contested A2AD environments where communication reliability and sensor fidelity are already degraded.
So deterrence itself starts weakening once gaps become visible?
Exactly, because once an adversary observes consistent penetration points, they can exploit those gaps to increase pressure and operational tempo. This transforms the system from a deterrent network into a stressed defensive posture, which fundamentally changes how the alliance must evaluate its overall capability.
So the system works, but not as perfectly as assumed? It holds under limits, but degrades under sustained pressure?
That is a more accurate framing, because the integrated network delivers capability, but only within thresholds defined by connectivity, inventory, and coordination stability. Once those thresholds are exceeded, performance shifts from optimal execution to constrained response shaped by real-world friction.
So Australia is not buying certainty, but conditional capability?
Yes, the Mogami, F-35, and Wedgetail ecosystem provide strong deterrence, but effectiveness depends on how the kill chain adapts under Indo-Pacific A2AD pressure. This means capability should be assessed not by peak performance, but by how long it can sustain function under stress before degradation impacts outcomes.
Then the real metric is endurance, not just firepower?
Exactly, endurance, resilience, and recovery capacity define real effectiveness in a contested battle space.
So the gap is not failure, but expectation mismatch?
Correct, and that gap may persist without structural adjustments to doctrine, logistics, and network redundancy. System shape options.
And if the system keeps evolving, can the gap ever fully close?